Simple interest versus compound interest. Simple interest refers to earning interest only on your initial investment. Using this formula of P, which is principal or initial investment, times the N, which is your interest period, and times the R, which is your interest rate or per interest period. So that's what you only earn. It's an interest on just initial investment year after year. Comparing that to compound interest, it's the interest paid on the investment during the first period, and it is added to the principal. During the second period, that interest is earned on the original principal plus the interest earned during the first period. And during the nth period, the interest is earned on the original principal plus the interest earned during the nth minus 1 period. To illustrate, we see here that the simple interest calculation is that for $1 today, and you invested it at 10%, will give you $1.10 on the first year. And then continuing with the simple interest calculation to the second year, you again refer to the same $1 times 10%, and it will give you another 10 cents earnings, and therefore it now becomes $1.20. On the third year, because you are investing again the $1, based on simple interest rate calculation, you'll be earning another 10 cents. So therefore, the 10 cents now is added to what you have at 1.2 for you to arrive at 1.3. Now comparing that with the compound interest calculation, the $1 that you started with will earn 10%, and it will become 1.10. And then in the second year, that 10% is now based on this 1.10 to become 1.21. And for the third year, the 1.21, which is principal and interest earned in the previous years, will be earning 10% to reach now 1.331 on the third year. So you notice that between simple interest and compound interest, you earn more with compound interest because you're earning interest upon interest upon interest. Let's now move on to understanding 5 major time value of money formulas and examples for you to know more about it. Future value. Finding the future value, or FV, of a cash flows or series of cash flows when compound interest is applied is called compounding. The compounding method is a process of accumulating interest in an investment over time in order to earn more interest. Therefore, the future value is the amount to which your investment will grow after a number of years. And to solve for that, the formula is FV is equal to PV times 1 plus I raised to the n, where FV refers to the future value, PV is the present value, I is the discount rate or interest rate or compound interest, and n is the number of years. So let's take a look at an example. In this example, the question is, what is the future value, or FV, of an initial $100 after 3 years if the interest rate per year is 10%? Applying the future value formula, we have there that $100 is the present value, 1 plus I is 1.10 because the interest rate is 10%, and it's raised to the 3, which refers to the number of years. And the answer we get is 133.10. Let's now go to another question. Will the future value of a lump sum be larger or smaller if compounded more often, holding the stated interest rate constant? As we can see in the illustrations below, it is a larger future value as the more frequently compounding occurs because interest is earned on interest more often. Present value. Finding the present value, or PV, of a cash flow or a series of cash flows when compound interest is applied is called discounting. That is the reverse of compounding. It is a process by which future cash flows are adjusted to reflect various factors. Discounting method. The process of which future cash flows are adjusted to reflect the following factors: preference for current consumption, expected inflation, and uncertainty in the future cash flows. Discount rate is the rate at which present and future cash flows are traded off. The magnitude of these factors can be viewed as a composite of the expected real return, reflecting consumption preferences in the aggregate over the investing population, or the expected inflation rate to capture the deterioration in the purchasing power of cash flows and the uncertainty associated with the cash flows. Therefore, a higher discount rate is required if there is greater preference for current consumption, or a higher expected inflation, or a higher risk perceived in the future cash flows. And a higher discount rate will also lead to a lower present value for future cash flows. Present value. It is the value in today's dollars of a future payment discounted back to the present at the required rate of return. It shows the value of cash flows in terms of today's purchasing power. In this particular equation, we will arrive at the present value coming from the future value equation, just through transposition. So we now have here the PV, which is the present value, is equivalent to the FV, or future value, times 1 over 1 plus I raised to the n. That in bracket is the present value factor, which is used as a multiplier to calculate the amount's present value. The present value also shows the value of the cash flows in terms of today's purchasing power. For example, what is the present value of $100 due in 3 years if the interest rate per year is at 10%? Applying the formula of PV equals FV divided by 1 plus I raised to the third. This is equivalent to $100 as our future value on year 3, divided by 1.10, which reflects the 10% interest rate, raised to the 3 being the 3 years term. And we will arrive at the answer of $75.13. Ordinary annuity. Annuity is a series of equal dollar payments for a specified number of years. Recurring payments such as the rent or an apartment or interest in a bond are sometimes referred to as annuities. When we say compound annuity, therefore, it means investing an equal sum of money at the end of each year for a certain number of years and allowing it to grow. Therefore, ordinary annuity is known as an annuity where the cash flows occur at the end of each period. Future value of ordinary annuity. It is a measure of how much a series of regular payments will be worth at some point in the future, given a specified interest rate. And for example, if you plan to invest a certain amount of each year or month, it will tell you how much you will have accumulated as of a future date. If you're making regular payments on a loan, the future value is useful in determining the total amount of the loan. In this formula, you will see here that it is FV for future value. PMT now is the equal cash flow or payment that you're receiving if not paying, and I is the compounded interest rate. That is the formula to be used for future value of ordinary annuity. Example for future value of ordinary annuity. If you're planning for a trip abroad and want to save $500 at the end of each year for the next 5 years in a bank where it will earn 6% interest, how much funds will you have at the end of 5 years? In the timeline, you draw it at 0, which is time today, and 1, 2, 3, 4, 5 years. And below those years, you have equal payment of $500. So in year 1, $500, year 2, $500, year 3, $500, year 4, $500, and on year 5, $500. So applying the formula, you will now put it at PMT, which is the equal payment of 500, multiply that by 1.06 raised to the 5 minus 1 all over 0.06, and we will arrive at $2,818.50 US. Present value of ordinary annuity. In contrast to the future value of ordinary annuity, a present value, or PV, of an ordinary annuity tells you how much money would be required now to produce a series of regular payments in the future, again assuming a set of interest rate. So you can compute now for the present value of an ordinary annuity with this formula, which is equivalent to the payment, PMT, times 1 minus 1 plus I raised to the negative n all over that of I. And if you forget what this formula is all about, you can just simply also compute the simple present value formula of each year, okay? And then from there, you can now add up the present value of those years, and the sum total is equivalent to the same answer you would have had you used this present value formula. An example of a present value of an ordinary annuity. What is the present value of a 10-year, $1,000 ordinary annuity discounted back to the present at 5%? In the timeline, you will see there that there's a 0 all the way to 10. And in each year, starting at 1 all the way to 10, you'll be receiving $1,000. So the question is, what are all of those future cash flows of $1,000 worth at present? Okay, so applying the formula of PMT times 1 minus 1 plus I raised to the negative n all over to I, we now assign at PMT the 1,000 and then multiply that by 1 minus 1.05 raised to the negative 10 all over that of 0.05, and we will arrive at the answer of $7,722.